right, ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DM Radio. Yours truly, Eric Kavanaugh, here, and we're going to talk about the foundation of the information economy, the foundation of the whole data world, which is of course, database. We're going to talk to Avthar Sewrathan. He is with Timescale Database. Very interesting things going on there. They've got a vector database, they have a time series database. We're going to talk about what that all means and how you can use it and where it fits into the world. And I'll just say, first of all, I remember like almost 20 years ago, I interviewed a guy named Dr. Michael Stonebraker back when I was working at the Data Warehousing Institute. And at that time, he was pushing a whole mantra of one size does not fit all. And his point was that at that time, and this is like 2005, the relational database had just won the market. Everybody used a relational database. Oracle, IBM, there were some others out there, but almost all of them were relational in terms of their format. There were a couple columnar databases. Sybase ultimately owned yes, Sybase was ultimately picked up by SAP, but Sybase IQ way back then was a columnar database, so column orientation. And at the time, Dr. Stonebraker was pushing Vertica, which also is a column-oriented database. Now, the reason you would have a columnar database is largely for analytics. And one of the key factors is that everything in the column should be the same type. So it's either an address or a phone number, and that means it's easily compressible and that means you can do analytics faster on larger amounts of data. So this is an old architectural approach, but there are many different kinds of database, and time series is very interesting. Geospatial is very interesting. You have to kind of sit back and think about how the database persists the information and then the access path, basically, because that's what it's really all about. How quickly can you then retrieve the data that you want? How quickly can you find it? How quickly can you retrieve it and leverage it, make it useful? That's what these different modes are all about. And Avthar is going to talk to us about a multi-modal database called Timescale. So Avthar, welcome to the show. Thanks so much for your time today. It's great that you know, of course, the legendary Dr. Michael Stonebraker. I love that name too. It's like that's a perfect name for someone inventing databases, right? You got to break that stone, like create new shards and do cool stuff. So tell us a bit about yourself and Timescale.
Totally. Thanks for having me on the show, Eric. And yeah, as I mentioned before we hit record, it's great to have interacted with Michael Stonebraker. He wrote a guest blog for Timescale, which we can actually put in the show notes about his a new company called Hopara and how they use some of Timescale's time series capabilities to visualize IoT data at scale. And so, we can dig into that a bit later. But pleasure to be on the show. Yeah, my name is Avthar. I am have the good fortune of leading the product effort for AI and vector data at Timescale. So leading up efforts to help make Postgres a better database for building AI applications. I think every company these days are either building new applications around the capabilities unlocked by LLMs or trying to figure out how to add LLM-based features to the existing application to kind of better serve user needs. So yeah, pleasure to be on the show. And yeah, as you mentioned, Timescale is a database company. We're really a Postgres company. So we help people use Postgres to power all the different kinds of workloads in their application, from time series events and analytics to more recently vector embeddings for things like retrieval augmented generation, otherwise known as RAG, as well as semantic search and things like that. So we're really a Postgres company and excited to tell you all about it and dig into some interesting topics.
Yeah, and I'd like to get into the different modes, and let's focus on time series first. And you mentioned IoT, which is a great use case. So time series, just to help people understand, in a relational database, you have tables. The tables refer to each other. They're very good for doing analysis of number crunching, basically running the numbers, trying to figure out how many widgets do we sell in this domain versus that domain. So they're very good at that sort of number crunching side of trying to understand what's happening in your business. Time series is very different because time series, you realize when you think about certain scenarios in business or in life, there is a cadence to them and there is a specific time series to actions like driving to the store or watching a baseball game or doing any number of things. And a time series database is designed, and correct me if I'm wrong, to really optimize analysis for time intensive concepts or realities. Is that about right?
100%. The way I like to explain it is that time series data is just data that changes over time. So as you mentioned, very popular in IoT, where you have all these different connected devices. You can think of sensors that are reporting statuses of, what is the temperature, what is the humidity, what is the state of this machine, every millisecond, every second, every hour. So there's also abundant time series data in fields like finance and crypto. So you can think of classical stock prices, stock tickers as they move. You want to be able to firstly store that information in a really efficient and cost-effective way because it's a lot of it. It piles up over time. You can imagine having a device or
Right.
thousands of devices that report every millisecond across multiple fleets of warehouses or centers that you might have. So storage, I think, is the first key part, like efficient storage and ingest. And then the other one, as you mentioned, is querying over time. There's a couple of different query patterns there. One is kind of what I call real-time monitoring, where you want to know the latest state of what's going on in your system or across your fleet of devices. And then the other one is historical analysis, where you're trying to do things like aggregate, billions of data points over time to try and find patterns, to try and drill deep into, specific locations or, having specific filters. So that's at a high level, time series database, a database that's specialized for this ingest of time series data, efficient storage, and really efficient querying. And what we do at Timescale is we allow you to transform Postgres, which, as you mentioned, is a well-known, well-loved relational database, and give it these time series superpowers such that you don't have to use a separate database. And with that, all the maintenance and all the data synchronization and all the upkeep with having multiple databases in your system. Um, so that's a little bit about how Timescale started. Part of the origin story of the company is the founders were actually trying to build an IoT company, an IoT
Mm.
platform, and they were using a specialized vector database and sorry, they're using a specialized time series database, and they found that it was kind of clunky, and they didn't really like the query language. They preferred to use SQL. And one day, engineers was like, "Hey, I think I have a solution in Postgres that can take advantage of table partitioning and can take advantage of materialization views." And within a couple of months, that led to the inception of what is now today Timescale DB and Timescale the company.
That's very interesting. And so there's this concept of a multimodal database, which typically refers to a database that can take multiple forms. So it can be an object database, a document database, it could be a vector database, which of course saves in vectors, mathematical formulae, a point, an array, basically in a certain direction, a certain distance. And we'll get to that in a minute and how foundational it is for generative AI and for these large language models. But you also have a time series database, of course, a columnar database, a relational database, a graph database, which is very popular these days because graph is really good at representing and then reflecting relationships between entities. So it's lean in terms of its storage, but it's very powerful in terms of how it reveals the manner in which certain entities relate to one another, right? Which is extremely important. And the point is that in certain environments, in certain use cases for certain workloads, you want to have this kind of database or that kind of database. And to your point earlier, typically you would either have to choose this vendor or that vendor. But if you go multimodal, then you can have one vendor. And there are some others that do this. I seem to recall MariaDB, which I'm sure you know is a fork off of MySQL back from when Oracle bought Sun, right? And they went and forked it the next day to create MariaDB. It's one of my favorite stories in this in this whole industry. It's kind of funny how that happened. But they do something like that. But can you talk to me about how that's possible with these extensions that you can have the same foundation for persisting information, for storing information, for enabling access? How can you then use an extension to do these other kinds of formats?
Fantastic. Yeah, I love talking about this. It's one of my favorite things about being in the Postgres ecosystem. To start from first principles, Postgres open source database, you have a core Postgres team of contributors and committers that are really focused on what I'll call Postgres core. This is, what you get when you download Postgres. And, I think part of some of the frustration that other projects have encountered in the past is that, the core team of committers, they have their own agenda, they have their own vision for the product, and, certain things that individual businesses might need that would be super beneficial for a certain segment of companies or users or just, people playing around might not necessarily be important enough to warrant time being spent by the core team. And so Postgres has this idea of extensions, which is, as the name suggests, a way to extend Postgres capabilities while not affecting how the core Postgres works. These are things that isn't part of the core Postgres capabilities, but they're extensions that can add additional capabilities on top of Postgres. Timescale, we're in the fortunate position to have a lot of experience building these. We've actually built more than 3 extensions. I'll talk about 3 of them now to extend Postgres for different kinds of workloads. And what that does is it actually makes modifications to the Postgres query planner in terms of how to handle certain kinds of queries and certain kinds of data types. So the first extension that we built is Timescale DB. As I mentioned previously, it already turns Postgres into this time series database, allowing it to efficiently handle ingest of millions and billions of data points and to query that data using time filters and to handle time-based queries really efficiently rather than the way that Postgres handles it by default.
Right.
Some of the other extensions, just to paint the full picture is, with AI today, vector data plays such an important part in RAG and search applications. And there's an extension out there called PG Vector that's an open source project. And what that does is it actually allows Postgres to handle vector data. It adds a vector data type to Postgres, allowing it to store vector data natively, and it adds a bunch of algorithms for semantic search, approximate nearest neighbor search, distance measurements, etc. That, as you mentioned, ordinarily you might have to use a separate database for it, but here you can still use Postgres. And I think part of the value of these extensions is twofold. One, as you mentioned, you don't really have to use a separate system or a separate database. But secondly, most often, I always say data doesn't exist in a vacuum. Most of the time, what you want to do is have certain operations that might be time series or might be vector search, but it relates to data that's already in your existing SQL tables or existing business data. And so part of the idea behind this isn't just that you don't have to use a separate database, but it's actually easier because you can actually join data from your other tables. And so you can do things like advanced filtering queries where you do a vector search, but you filter on some condition that's in your customer database. And that saves teams a lot of hassle because you don't have to worry about data sync, data maintenance. It gives you one source of truth rather than trying to piece together, oh, you have this query defined this way, or this is the filter in this other database. So that's the whole idea of extensions. And I think the way we see it is it allows you to get more from Postgres while still keeping the foundation and the core really reliable and chugging along. And those extensions are really room for experimentation. And that's kind of where we fit in as a company in the Postgres ecosystem, trying to push the boundaries, trying to build useful things that, customers and businesses and individual developers can use today.
Yeah, that's a very interesting point. So if I understand it correctly, are you suggesting that I can save a big chunk of data in Timescale and then apply different types of analytical processing to it? In other words, I can apply graph processing, I can apply relational processing, time series on the same actual stored data. Is that correct?
Yeah, so let me give you an example. There's a company out there that is one of our customers. They're called Open Source. We have a webinar on YouTube that goes into their use case. But they're a super interesting company because they combine events data from GitHub. And so they have a whole data source of GitHub events, changes to different repos, and they combine that with vector data, and it's in the same table. And so what you can do is you therefore can perform different kinds of queries on the same table. You can perform a bog standard relational query, show me all the repos that have more than 10 contributors, for example. That's an easy
Hmm.
query to run. You can also do a time series query that says, hey, show me the average number of contributors for all repos that have updates in the past 3 months, for example. That's a time series query. And that it does involve some relational as well. And then you can also do a similarity search query or vector search query where you can create embeddings on part of the data. So let's say you have a text column that has descriptions of git commits to a certain repo. You can then search those commits and say, hey, for all repos with more than 6 contributors, can you tell me what's new in the past 6 months? And then you
Wow.
can actually through using similarity search and running it through an LLM afterwards, you can actually get cogent answers to that. And they've built a really wonderful application around this. Again, the company's name is open sourced. And so that's just an example of how, as you said, it's the same table, it's the same maybe set of tables, a same system, but it allows you to have all these different kinds of all kinds of utility just from the same database. And that's super powerful, especially in the age where, you do have smaller engineering teams, you're trying to move faster, you're trying to focus on business value rather than maintenance and data plumbing and things like that. But hopefully that gives you a little taste of what's possible.
Yeah, those are some really good examples too you gave of these queries that have specific parameters. I want to know within a certain time frame who did XYZ, what's in this information. And that's a very powerful query. That's different from a standard SQL query, right? Where you're just grabbing rows and pulling it all together. So and see, I've always been fascinated by the time series component because it's very important in any number of analyses. If you're trying to understand why are people coming into the city at this time, well, that's a time series question. When you can see how many people are coming in at a certain time, it's not just an average, for example, which would be very misleading in that kind of context. You want to be able to get really granular truth pulled together from multiple sources and multiple formats. And that's a very interesting argument you have here because you look at the database sprawl these days, and if you go back to, I mentioned 2005, back then there were very few databases. Now there are like 430 of them or something. They're in production that are known quantities that are being used by organizations in the world today. That's a lot of different tech to understand. And if you have, as you suggest, a small team where you're trying to build something new, something interesting, something for AI, for example, it's going to be easier to use one database that has multi modes as opposed to 4 or 5 different databases where you have to keep them all up to date, all the patches that you get, things of this nature, the usability of it. And then, of course, just the fact that they have to then talk to each other instead of it being one environment that you're talking to. I'm guessing all these things combine to make this multimodal approach very, very interesting. And I'll throw you some more questions over to you after the next segment starts here, folks. But send me an email if you want to be on the show, info at dmradio.biz. That's info at dmradio.biz. That comes right to me. We'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio, talking all things time series database and multimodal database with Avthar Sewrathan. And he's with Timescale DB. They are a Postgres database with lots of extensions, including vector databases. So let's dive into this, Avthar. This is a very interesting space. And I am very curious to see how this whole game plays out. And in fact, in the next segment, maybe I'll throw one of my theories at you and see what you think. But for now, let's talk about vector databases and similarity searches in particular. They're very, very important for these RAG models, as you suggested. A lot of companies are now trying to leverage the power of these large language models and even small language models, other foundational models. There are many, many of them. And bigger is not always necessarily better for certain use cases. I'm hearing more and more about companies focusing on specific ontologies for a certain industry or vertical, and then building a small language model around that to really optimize the accuracy of the responses. Because a large language model, it's large, and so it's unwieldy. It's got all kind of stuff going on. If you go with a small language model, you're much more likely to get success fairly quickly because it is so narrow and it's very, very focused. But regardless of your approach, these vector databases are very important because, and here's my assessment of what's going on. It's very interesting stuff. The large language models are really consensus engines to a large degree, meaning they've been trained on tons of content of text to do text generation, also images, of course. So anything that is widely published about, like how a computer chip works, or how a radiator works, or how to cook spaghetti, for example, anything that's been widely published and then widely trained or deeply trained for these models, it's going to do an excellent job of reflecting back to you what is essentially an average of everything that it's seen in syntactically correct format, which is what's so cool about it, right? If it's a fringe topic, that's where they start to get into some trouble. That's where you get these hallucinations. That's where you really want a vector database loaded with your embeddings, which then basically are conversions of text to numeric values. And then, of course, when it comes back, you're converting it back to text or decoding it, right? So, talk about why that's important and how your vector database is filling that gap.
Fantastic. Yeah, I really love the way you frame it. The easiest way to think about it is vector databases are one solution to the problem of hallucinations that happen in large language models. And you're exactly right. I think the key part of LLMs is that they enable human reasoning at scale and human reasoning really cheaply. And,
Hmm.
as you've identified, a lot of business applications, they require really specialized data sets or specialized knowledge. And that's where vector databases come in. And so vector databases, they allow you to store vectors really efficiently. So vectors, you can think about it, you mentioned it's like an array. I would think about it as just a compressed version of information. So you can say a
Mm.
vector for an image is just a compressed version of the image. It retains kind of the essence of that image, or a vector of a piece of text or a paragraph of text retains the meaning of that text in kind of numerical format. And so what these models allow you to do and what vector databases allow you to do is really search by meaning for relevant information. And so the goal is to pass information that's most relevant to the language model such that they can do some advanced reasoning using data that might not be in their underlying training set, or telling the LLM, this is the most important data to use. For example, let's say,
Right.
I'm trying to answer a question about the timescale documentation. I would have the docs embedded in my vector database. And when a user asks me, hey, what are some of the advantages of using timescale for IoT? Uh, you know, then I would go and perform a search against my vector database to look for documents that are similar to that query, and then take
Hmm.
that and then pass it through an LLM to then take the raw text and summarize it and maybe give it to the user in a bullet point answer. And what's most important here to remember is the whole idea of relevance in the queries. So similarity search is one thing. The next level you can go up is maybe similarity search by filters. So this is where Postgres as a relational database excels, where you don't just want to look for data that's similar, but you want to constrain it maybe to a certain business unit, or maybe to a certain customer, or maybe a combination of those two. You can have composite filters, for example. This is actually something that where Postgres really excels. And then lastly, to take it to another level, it brings in the time element that you talked about, where a lot of these AI applications, you don't just want data that's semantically similar, but you want data that's recent or up to date or most recently updated. And so that's where, some of the advantages of keeping this all in Postgres, keeping it in Timescale, that really comes to the forefront. And some of the things that I've been privileged to be a part of is some things that we've built to take Postgres and vectors to the next level with two new extensions. So Postgres has an extension called PG Vector, which is an open source extension that allows it to handle vectors and do similarity search. But what we noticed after talking to customers is that when you're dealing with large scale data sets, so think millions of documents, or think millions or hundreds of millions of events that are coming in, that search can be very slow, even when you use approximate algorithms. And one thing we know about AI applications is that, we want answers fast. Like, we want low latency, we want really good user experiences. And so what we built is an extension called PG Vector Scale, which is a complement to PG Vector. Again, this idea of building on open source software. We've added some new indexing types based on state-of-the-art methods to allow you to have faster vector search queries using the streaming disk NN index, that's what it's called, as well as cheaper scaling costs, where it actually uses a certain kind of compression algorithm called binary quantization. We call it statistical binary quantization, that allows you to reduce the size of the vectors on disk, and on disk and in memory. And the cool thing about that vector indexing algorithm is actually takes advantage of keeping vectors on disk, so that
Hmm.
you can actually, as you scale up your number of vectors that you have in your database, you don't have to scale your memory in like a one-to-one way. And as we all know, memory is much more expensive than disk. And so that allows companies to build in a bit more cost-effective manner. So that's one thing. And then the other extension that we built is called PGAI, which is really bringing AI models to the database. So I'll give you an example. Let's say you already have a database full of data and you want to create embeddings on it, or you want to do LLM reasoning on it. Let's say you have a column and you want to create like a summary based on information in that column, but you have like a million items in your database. The PGAI extension allows you to do things like embedding creation and LLM reasoning using super popular models like open source models from Olama, OpenAI, proprietary models from OpenAI, Cohere, and Anthropic. And so this is part of something that I like to call the rise of the AI engineer, where
Hmm.
more and more, AI capabilities aren't just constrained to ML teams or applied scientist teams or research teams. Software engineers, DBAs, data engineers, they now have the ability to implement AI functionality in applications. And I think, as a result of the rise of large language models, AI engineers, we'll see this more and more. And we're proud to build things that kind of enable that at Timescale with the PGAI extension. So hopefully that gives you a good flavor and of kind of vector data in Postgres, as well as some of the new things that we built to address scaling and ease of use issues that we've noticed.
Yeah, that's very interesting. And this concept of an AI engineer, I think, is quite fascinating because now we, of course, know what a data engineer is. It used to just be called an ETL job. Right now, it's a data engineer that stands for extract, transform, load for anyone who's not familiar with the industry. But that's how you used to always move data, and it's still everywhere. ETL is never going to go away. There's ELT, of course, but a data engineer comes along because you can get more sophisticated data pipelines, and you get very clever about how you're moving data from a source into an application to solve some particular problem. But you bring up a very excellent point, which is an AI engineer needs to really understand the end-to-end workflow and be able to optimize that. Because if you don't optimize that, you're going to be spending tremendous compute resources, tremendous engineering resources, and it's just going to take you a heck of a long time to do something. It's like if you don't optimize how you leverage a plane and your automobile and a bus to get from here to San Francisco, and you try to walk from Pittsburgh to San Francisco, guess what, man? You're going to take a long, long, long time to do that. And
Exactly
there
right.
are there are some deep chasms in this typical workflow, which an AI engineer should be able to figure out, understand, and then code for. Is that about right?
Yeah, I love that analogy. I think that, traditionally, A, AI was in the form of, teams would be building their own airplanes and vehicles and buses where you would actually build your own
Right,
models. But with the
right,
rise
right,
of LLMs and off-the-shelf models, it now
right,
becomes a question of, hey, we have all these capabilities that are brought to us by GPT 4.0 or Claude Sonnet 3.5 or, Meta 3, Llama 3.1. And it's a question of how do we utilize those capabilities? How do we leverage those in the right places and make the right trade-offs? Again, I love this analogy of like plane, car, and bus, where it's like for the right kinds of jobs, are we using the right model? Are we using the right vector
right,
database? Are we
right,
supplying the right kind of data? And so that's why I think the job of the AI engineer, if I had to summarize it, is you're using AI models to build useful products that have AI capabilities. So distinguishing it from the researchers that are working on these models, all these folks at
right,
OpenAI and
right.
Anthropic, these are the everyday engineers, in my opinion, where more and more people, whether you're a full stack engineer, whether you're a backend engineer, data engineer, even DBA, a lot of folks that we work with are responsible for the database. They can now start integrating AI capabilities into their applications from where they sit in the stack, and they don't have to go and train their own models, and you don't have to have ML engineers to productionalize the models, etc. That's super exciting for me. The way I think about it is like it's collapsing the stack where, the lines are kind of blurred between, which team in the company is responsible for AI. Now, the engineering teams, the data engineering teams, the product engineering teams can be unleashed to work on that rather than having that company needing to come up with those models. And it's a totally new field of engineering, in my opinion, and it's evolving very quickly. As you said, vector databases are a big part of that. There's also all these things around orchestration tools and how do you kind of ensure that you're getting your data in the right format to be useful in your AI application. There's all these agent orchestration platforms. So it's a rapidly
Right.
growing space. And once again, I think your analogy of like picking the right tools for the job is really apt. And I think this is something a lot of engineers are kind of working through as their companies navigate, how do we integrate AI and what's our AI strategy and how do we build useful things for our users using LLMs?
Yeah, right. And I'm reminded of something. Uh, and this gets to your point of a moment ago, using the right tool and the right use case. And there are so many models. I mean, Hugging Face, you can just go on there and grab like thousands of models, right? So they're all over the place, knowing the differences between them, whether it's what they solve for, how quickly they solve for it. Are they ideally used for large data sets, for smaller data sets? These are all very important considerations to go into what you build. And instead of trying to build it all yourself from the ground up, good grief, no, use what's already out there, especially if it's an open source model. And I'll get to one of my pet peeves is seeing people misuse the tools and then complain about the tools. So there was this famous story of the New York Times editor who was chatting with ChatGPT and it told him to leave his wife and all this kind of stuff. He was trying to see if it's sentient. It's like, dude, it is not sentient. Okay. Like you're misusing the tool, and because of that, you're getting these goofy responses. So you have to understand the context and what it's made for and use it appropriately, right, Avtar?
100% right. I think one of the best examples I can give here that I've experienced personally is in the choice of model to use for the kind of application that you're building. And, on Twitter or on X today, you see a lot of debates about open source versus closed source models, for example, and, which one is better, and this, team open source or team closed source. And I think in reality, what you have to look at is can you actually leverage the right models for the right job? And there's a customer that we have that, they actually leverage several different models for the application that they're building, where they require really complex reasoning. They use a closed source model because they're kind of state of the art in doing reasoning and planning and things like that. But when they just need something like maybe summarization or maybe categorization, they
Right.
actually host an open source model, and that's what they use for that kind of job. And so I think this theme of, not falling into binary thinking of, oh, I have to only use closed source models or I have to only use this kind of thing, and trying to understand like what am I trying to do? What are the goals that I'm trying to achieve, and what are the models and tools that I have available? That's super important. I think we also see this in the vector database space where, we kind of fall into, every engineer is guilty of this. I know I am, of shiny new tool syndrome, where you see, oh, this is the latest thing. We got to try and use this, where what we've realized is like the old and boring tools are actually great for the job. Like Postgres is going to be good
That's
enough for
great.
like 90% of companies. And,
Right.
the work that we're doing to kind of extend Postgres and kind of remove these limitations one by one. One, I think is super exciting, but two, it just allows people to like, get things done more easily. And sure, I think there's a time and a place for specialized tools. For example, like most of these vector databases came out of one of some of the very large tech companies, for example, Face at Facebook, Annoy at Spotify, for example, these really large companies dealing with like huge data sets. Most of the time, companies are going to be orders of magnitude below that. And so using these tools that are good enough for 90% of the job, 95% of the job, once again, it's about making the right choice for your requirements. And, I think a lot of businesses today, really, it's a frenzy in the AI world today because everyone is trying to have an AI story. And I think the ability for an engineer to say, hey, I can use familiar tools for the job, that's super valuable. And I think that's what we've heard about why developers choose tools like
Right.
Postgres for
Right.
building AI applications.
Right. There, I mean, there are foundational technologies already here. If they get the job done, great. If you need to do something else, that's when you explore opportunities to use some of the newer things. But no doubt, when stuff works, if it works in efficient fashion, use it. Don't lose it. Focus on it. Well, don't touch that dial, folks. We'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio. Fascinating conversation with Avthar from Timescale DB. And Avthar, I'm going to throw one of my theories at you. When I look at the industry, and there are some obviously major players these days, you've got Snowflake, which really took the world by storm, especially as Hadoop was faltering. And I was one of the skeptics of Hadoop for what it's worth. I was like, are you guys sure? It seems a bit kludgy to, I mean, it's good for certain things, but MapReduce was not going to solve the world's problems. But then Snowflake kind of spins out of that into like a juggernaut. Databricks around the same time, they're obviously huge players. Well, Databricks went and bought Mosaic ML for $1.2 billion dollars or something. I had Naveen Rao on the show the week after that transaction cleared, so that was pretty exciting stuff. And at first, Snowflake was, not really paying much attention to this LLM thing. Now they've got Cortex, and they're obviously focused on it. But what I think is fascinating is that with these LLMs and with this concept of hybrid search now, where you can search both from a structured query language perspective and from an LLM perspective with this RAG model, you can get the full and complete answer. And a lot of these old business intelligence tools are really just giving you a little window into the world. And it's because of how we got here. It's because we had to strip out all the context to just get the numbers into these relational models through thin pipes to slow processors, expensive storage. All these factors were the case years ago. Well, they're not really the case now. Things have changed. So I see a tumultuous shift coming in the decision support business, wherein forward-looking companies are going to use these RAG models. They're going to keep some of their meat and potatoes, SQL queries, and those kinds of things. But this hybrid search is going to, I think, fundamentally change how business intelligence is done. And that industry needs to innovate like ASAP. What do you think?
I definitely agree. I think one of my maybe controversial
Good.
controversial points is I think dashboards and BI tools within 20 years or so, maybe 10 years or so, will no longer have a need for them. It'll just be you asking a question and the LLM will create
Right.
kind of custom
That's right.
information for you, whether it's a dashboard and then an explanation and then an explanation tailored to your expertise level and a breakdown of definitions. It's all going to be custom. And I think what you highlight on is this idea of like the reason why companies like Snowflake and Databricks are investing in models is because LLMs are super valuable, but data is really where the value is. It's like applying LLMs and the reasoning capabilities of them to your company's data. And we're fortunate to see this at even a company like Timescale. We're smaller company than those ones, but we have thousands of customers, and one of the key things that they like is this idea of, as you mentioned, you have RAG, you have search capabilities, but you also have a lot of value locked away in your structured data. And so that
Mhm.
ability to build, for example, an AI agent or just a workflow that might combine uh, results from a search as well as a SQL query, that's actually super exciting. And we have some upcoming work at Timescale that's going to make that a lot easier for developers. Um, but I totally agree with you. I think that like what this allows you to do is as you bring LLMs closer to your data and as we get better at integrating LLMs with our own data, you can unlock so many different kinds of applications. And we're already seeing this, for example, I'll give you one thing that I'm seeing at Timescale where you have an IoT application and in it, it might be an electricity management application for buildings. For example, we see this is quite common where you have a bunch of graphs about your usage and building managers want to know, which units are using more electricity, how's the trends, etc. And that ability now, for example, in addition to having that data, those dashboards
Hmm.
populated from SQL queries, is you can now ask questions about trends, about patterns over time. You don't
Wow.
need to put a ticket to your data analysis team. Maybe you don't even have a data analyst team to answer
Right.
those things. And it actually enables either decision makers or even end users who want to know, hey, why is my bill so high this month compared to last month? Oh, it's actually only a 20% increase. This is normal. This is fluctuations, or maybe this is common in winter. Most customers see this, etc. It allows you to actually build better applications because you're doing more useful things with data. And I think, there was a whole thing around big data and the importance of data. But I think when you combine AI and data together, that's when really exciting things start to happen. And so, I definitely agree with your theory. It may play out slightly differently, but in principle, this whole idea of having more customizable interfaces and just interesting applications when you allow LLMs to interact with your data, that's something I can definitely get behind.
That's so interesting. And one of the things that Naveen Rao said to me that I thought was compelling is that, and I threw this out to him and he agreed. I said, it seems to me that you have to be a big enough company. Obviously, you have to have enough resource to do this. Not every company can do it, but Fortune 2000, even Fortune 3000, I think you can deploy a small language model in your data center, build your own model, train it on all of your data, CRM, ERP, support tickets, anything you've got, the corpus of emails, whatever you've got in there. Again, you have to do it correctly and pay attention to curation and so forth. But I think that's a real thing. And he said that's what they tell their clients. They said it's not that outside the your reach to have your own model. Now, the downside is, you know, that OpenAI is going to keep innovating. You know that Gemini is going to keep innovating. So how do you allow yourself to capture the innovations, and OpenAI in particular, because it's closed now, right? It's not technically open, it's closed in terms of what they're building. But still, it strikes me there's a whole heck of a lot of advantage to having your own model in your environment that you control. What do you think about that?
I think that's very interesting. I think one of the things that I I think the jury is still out on is what sorts of ecosystem should you be investing in? Should you be trying to train your own model, for example,
Right.
fine tuning, or should you try to train your own model from scratch? Should you try to fine tune existing open source models, or should you use closed source models and build RAG systems, or is the answer actually a combination of all of them? And I think what's interesting is that these closed source AI companies like, for example, Anthropic and OpenAI, their goal is really to push the capabilities. And I don't think we would be as excited about AI and see as much progress if those labs didn't exist, if they weren't trying to push kind of frontier model capabilities. But I think, as you said, for some of the business applications and what we're seeing now is that open source models and fine tuning them or even building RAG systems with them off the shelf, they're getting better and better. And I think the
Hmm.
rate at which they are improving makes a lot of sense for companies to invest in this. And so what we're seeing as a pattern is companies starting off building proof of concepts or proving value with closed source models, and then trying to figure out, hey, how can, once we've proven out the value, how can we make this cost effective? How can we have more control? How can we have more data privacy with these open source models? And I think what's really interesting is that open source models, um, I think the value of open source and AI infrastructure can't be underestimated. And I think that's kind of what maybe Naveen Rao and the folks at Databricks are kind of selling there, where it's like, hey, you trust a company like Databricks, you trust them with your data, and you trust the models that they have. But I think the cool thing about open source is you can actually take that model. You know that, even if the company doesn't do well, you can still have access to it. And this is not just a theoretical idea. We've literally seen this in the industry with a company like Stability AI, whose CEO left the company. Stability are makers of image models, for example. And there's developers that are like, hey, I still use Stability, the 3 models ago, their thing, and my app still works fine, even though the company is in turmoil. So I think that, once again, keeping up with the capabilities of frontier models and seeing what's possible for these kind of like complex agents and stuff like that,
Right.
they would definitely be useful. But for, I think, more and more, a larger percentage of business applications, open source models and fine tuning are definitely becoming more attractive and more interesting.
Yeah, and I'm a huge fan of open source. Can I tell you, I years ago we actually built our own software, which I wanted to use. I call it Media Lens, and its purpose, it's a content aggregator basically. You give it handles you want to follow on Twitter, you give it keywords you want to look for, and then it hits the API. It finds anyone who has tweeted an article link with those keywords, and then it parses, it actually scrapes the content, post persisted in MongoDB, and helps you build a content lake over time. And our first use case was around open source. So we have a site inside open source because there's so much happening. And to your point, it's now transparent to the industry, which means anyone can build on this stuff. Now, I know there have been some disruptions in the open source force, if you will. Click, of course, bought Talon, that pulled the string on the Talon open source version. There is pressure I've heard from folks at DataStax and other places that, at the end
Cockroach
of the
DB is
day,
another example,
it,
most recently.
which one?
Cockroach DB, I'm not sure if you heard the news about this, was a couple of weeks ago.
No, they went closed source too. Wow.
Some
Wow.
licensing changes. Yeah, yeah.
Yeah, well, they're feeling the pressure, man, because someone's, there was a joke about Amazon strip mining some of the open source stuff, but they seem to be getting religion too. But folks, our next break is coming up. Podcast bonus segment is coming up right now. You're listening to DM Radio. Okay, folks, back here on DM Radio with the podcast bonus segment with Avthar from Timescale DB. We've had a fantastic conversation about time series databases, vector databases, multimodal databases built on Postgres. So Postgres has this very solid foundation, open source. I love open source for lots of reasons, Avthar. I've been tracking it for about 20 years now. And when I first started looking into it, was right when the Apache web server, which was the first product out of Apache, had surpassed Microsoft for a web server. And I remember thinking to myself, huh, at the time I was researching service-oriented architecture. I worked for the Data Warehousing Institute, and I'm kind of doing the math in my head, thinking to myself, huh, this is very interesting. And it doesn't really bode well for large closed source software vendors like an SAP or an Oracle or some of these big guys, because theoretically, if you have service orientation and you have this open source model, you should be able to mix and match and swap and replace component parts and still keep going well, because continuity is very important. Nobody likes vendor lock-in. I mean, I think that's one of the big knocks over the years on Oracle is they were such bastards with their lawyers coming and knocking on your door about your licensing. And, Microsoft did some of that stuff too. And I think the open source community really kind of spun out of a desire to get those claws out of the enterprise and say, hey, guys, can't we just, collaborate, work on something, and then build the foundation? And now it's climbing up the stack. It's in networking, it's in data, it's not just the operating system anymore. So open source, I think really is the beating heart of innovation in Silicon Valley, and I hope that it really continues to be strong. But what are your thoughts?
I couldn't agree more. I think Timescale as a company, open source at our roots. We have a product, the Timescale DB product. There's a version of it that's Apache 2. Um, and we've done things to kind of protect ourselves and make sure that we can still have a thriving business. But we've never given up the values of, making software freely accessible and allowing really generous use of it. Two more examples I'll give is for the PG vector scale and PG AI extensions. Those are completely open source under the Postgres license. And I think the reason why I fought so hard to do that is because I think open source is so important to increase the pace of innovation in the AI space. And I think for the arguments that you've made, the reasons that you've gave where, you can choose things with confidence, you can free yourself from vendor lock-in, or at least you have the option to self-host, for example,
Right.
in the case of Postgres. And I think all these things allow you to like build with confidence and to actually
Mhm.
focus on making progress more quickly. You don't have to spend, weeks or months trying to contemplate, oh, should we go with this closed source vendor? What are the implications? Are they going to price us out one day? Like, what's the
Right.
issue?
Right.
Um, and I think because of what's at stake in AI, meaning that like the whole world is basically going to get transformed by this. And I think a lot of folks are skeptical, but I think over a long enough time period, when we see Apple integrating AI into the iOS ecosystem, I'm super excited about that. But I think it's going to transform everything. And I think, as you said, the foundations of this have open source at their roots. For example, Apple, some of their models are open source, from the models to the vector database to the application frameworks, etc. I think what that allows you to do is innovate faster. And I'll give you a concrete example. When we were building PG Vector Scale, we saw some problems with PG Vector, and we said, okay, how can we solve this? And it wasn't quite possible in the existing framework. And so we implemented a solution in PG Vector Scale, and combining those two things together allows Postgres as a whole to be more attractive than closed source alternatives. And so that's an example of, open source. They say it's better for innovation because the code is open, because anyone can build the things that they need. I definitely think it is a foundation, and it is super important if we're going to see, useful and exciting applications being built. Um, yeah, that's basically, I couldn't I can talk about this for 30 minutes more if you want, but
Yeah.
I think we don't have the time.
Well, I do love open source, and like a couple of cool quotes I've heard over the years are bad code goes away. That's one of the keys because you get bugs in these systems. I mean, there are bugs in major enterprise software applications all the time. They're all always there. One of the fun comments I heard years ago from one of my best friends in the business, a guy you may have even run across, Mark Madsen. He was an independent. He used to be client side independent analyst for years. Then he was at Teradata for a while, and I was independent again. But he told me one day, he goes, it'll take 10 years to find the edge cases that will crash a database. Right? 10 years in production before something happens, you're like, oh, that didn't work. And the point is, it's complex as hell, right? It's really complex. And the reason why you see people building on top of a Postgres foundation, for example, is because it works. And we know it works. and there's a group of developers. There's a whole community around this. That's the other side of the equation too, right? Is that you got a community of developers who understand it and keep it rocking and keep it rolling. And that's stability. So now you don't have to build, just like we were saying with the models, you don't have to go build your own models. You can if you want to, but you should at least look and see what's available for use, because there's so much. I mean, you could have a whole team that does nothing but investigate available models these days, right?
Exactly. And I think the cool thing about open source software is, as an individual engineer, you think about lowering the barriers to innovation in the world as a whole or in the USA as a whole. And I think the open source industry is so important, from Postgres to open source models and things like that. I think what Mark Zuckerberg and folks are doing at Meta with the Llama models is super admirable. Even though it is kind of selfish and in their business interest, it still has great
Right.
externality effects. And I
Right.
think that as a developer, the time where you can build software that is zero cost to you, maybe you pay for some hosting, maybe you host it locally, it's never been a better time. And I think there's never been a better time to be a developer, to be interested in AI, to be trying to build useful things. And I think open source is a huge part of that story. And hopefully that trend continues. And, we still see more innovation and open, free software. We're playing our part of that in Timescale by making the two extensions that we built, PGI and PG Vector Scale, open source. And I hope that continues throughout the industry.
Yeah, I commend you for doing that. I think you're on the right track here. Open source does help everyone. It's like a rising tide lifts all boats. That's the case with open source software, and it keeps climbing up the stack. Software-defined networking, storage, the data space is, of course, white hot, analytics, AI, all this stuff. And I agree with you. I had to give some props to Meta, and I'm not a huge Facebook fan, to be honest, but some of the things they've done. But I have to say that is very cool, because it just opens the door to so much more innovation for whoever wants to spend the time and resource to dive in. It's there. You can play with it. It's a big deal. Look this gentleman up online, Avthar Sewrathan from Timescale DB. Folks, send me an email, info@dmradio.biz. You've been listening to DM Radio.